Well, welcome back for part 2 of this week's Apex lesson. We're still in enthalpy and reactions, and today we're going to talk a little bit more about graphs and numbers of using enthalpy, which enthalpy is just a measure of the heat in chemical reactions. Okay, and so remember, whenever you see the change, or that triangle, that just means change of it. So your energy, your heat changes in a reaction, and the energy that's stored in bonds. Now, for molecules like this, they're rearranged, the bonds are made, they're formed, or they're also broken. So a lot of that will either release or require energy. So last time we just wrote the word energy at the equation, whether it was endothermic or exothermic. So now, though, we know there's a numerical number, kilojoules per mole of energy that is released. So this right here is an exothermic reaction because the energy is written on the product's side. Okay, so propane is formed with pure carbon and hydrogen gas, H2. This energy is released as an exothermic, so they write on this side. Okay, so with this, we can look at the formula or calculate the enthalpy of formation. Okay, it's required to form just one molecule. But the whole time, the reaction, we call it the enthalpy of reaction. Okay, so, and I understand this gets a little bit confusing as it goes different ways, but what we're going to look at is the products, the enthalpy of the products, subtracting the enthalpy of the reactants, and getting, is it a positive, is it negative, is it, greater than 1 or less than 1. Okay? Now, when we look at this, for the combustion of propane, including the enthalpy of reaction, now we know that it's going to give off 2,220 kilojoules per mole. Now, I'm a little ahead of the game, but when it's a positive number, we're going to know that the product's at a higher energy than the reactants, meaning it's giving off, okay, the energy. So exothermic, it's a positive number, it's written on this side of the equation. Okay, so the answer is going to be C. Okay, it gives off heat, and that means the product. Okay, so try again. Okay. So in the next page, we're going to look at the graphs of it. It's a little bit easier for me, and I think, to see it in a graph, like this one right here. Okay, so what they do is, this is the products on the, this is the reactant. Okay, products are on the right side. I call them products, okay? So reactants are what you start with, and it goes to the reaction, and this is the products on the right side. Okay, this is the potential energy of this reaction. So, which one has the higher potential energy? Is it the reactants on this side or the product on that side? Which one's higher? Okay, you just look for, okay, well, if I'm measuring, this is higher on the graph than that one, so it's going to be product. Okay, that's all you got to do. So I like looking at the graph, it's a little bit more visual. Okay, so then we look at this one. Okay, so we are now looking at liquid water turning into hydrogen gas and oxygen gas, so the breaking apart of H2O, and it's breaking down to H2 and O2. Okay, and with that, we have the higher potential energy at the end than what you start with. That means the products have more energy than the reactants. So the products must absorb this energy, take in energy. So what we know is that the heat, you must take that in, okay, and you have more heat at the beginning, okay. A little bit easier to see the comparison. What I like to do and what you look at is, okay, what's going on here? Okay, so I look at the potential energy from combustion of propane. I'm burning propane gas, okay, with O2, and I make carbon dioxide and water. Okay, in this reaction, the reactants have more energy than the products, so that means that heat is given off at the end, okay? So the potential energy is lower at the reaction, okay? Correct. Really, what I'm going to show you, though, is here's kind of the visual of the two different reactions. Whenever you have an endothermic, okay, where energy is absorbed or taken in, or energy is written in the reactant side, okay, you start with the lower graph and then it gets higher. So this is going to look like endothermic. Okay. When it's exothermic, energy is written at the end. It's products. It's given off. Okay. You start out with more energy in the reactants, and the products have less because they've given off the energy. They don't have it anymore. Okay. Whereas endothermic, you're taking in this product, this energy, this taking in this heat into the products, so they have more at the end. Okay. So it's a nice visual to kind of look at. If the graph looks like this, endothermic. If the graph looks like that, it's exothermic. Okay. A little confusing, but having the visual or side by side, you can then identify which one's which. Okay. So, looking at this, and I already did this one, so let's go to the next one. So let's practice. Okay. So we're looking at the two different, which one's an exothermic? Okay. So I look at this too. Let's go back here. Exothermic, I want a higher on the reactants, lower product. Okay. So which one has higher, lower product? Okay, let's see, it must be B. Yep. Okay. So the heat is given off, so at the end, the products have less because you release that heat. Okay. Confusing? Yes. But I think you can get through it. Okay. So let's try a few questions on our own. So let's just look at the diagram by itself. So which point of the graph to the left indicates the potential energy of the products? So where are the products again? They're on the right side. Okay. What is the maximum potential energy? Whenever you see the word maximum, that must be the greatest. So C up there. Okay. Now this one's a little bit weird, and I didn't mention this kind of before, but which energy change on the plot on the left indicates the activation energy. So how much does it take to start, to go through the process? It's going to be F. This is the activation energy kind of going through. Now, which energy is the difference between the reactants and the products? So the reactants are here, products are there, so the difference is G. Okay. And then is it exothermic or endothermic? And you're like, which one again? So let's bounce back. So endothermic was lower here, higher at the end. Exothermic is higher at the beginning, lower at the end. So higher at the beginning, lower at the end, exothermic. Good. Yay, 100%. Okay. The last part of this is kind of something I mentioned in the very first part, is that you have a positive and you have a negative amount of energy. Okay. Endothermic, your energy is being taken in, okay, and you have a positive number, okay, and it's greater than 0. For exothermic, when you release energy, okay, in the reaction, you have the change of H being negative. It means it's less than 0. Okay. So, let's see, review these questions. If my computer will load. There it goes. Okay. So now we have this idea. You have this liquid water being turned into gas. What? Which describes enthalpy? Well, when we have liquid, think of it when we're boiling water and we're changing into gas. Okay. If you're boiling water, where's your, pot? It's on the stove. Okay. So you're adding heat to it. So the heat is at the beginning. It's an endothermic reaction because you're putting in heat to this reaction, this energy. So if it's endo, if you go back to that, remember endo, it's greater than 0. Okay. That's correct. Okay. You have to boil water, it's endothermic, and you have a change of H always being positive. Okay. This one's the opposite. Well, if it's opposite, you probably know the answer is going to be opposite. But anyway, you have gas, so that water vapor, now cooling down, condensing into liquid. It's an exothermic reaction because it's giving off heat, it's cooling down. Okay, so it's going to be less than 0. It's an exothermic reaction. Okay. Now this one's not too bad. You got to read it. I know it's a little bit small, but what molecule releases the most energy when it's formed? Well, you look at the number. Which one's the number? It's the largest negative number, releasing the most energy. Sodium chloride salt is Okay. Now when we look at, okay, if we're forming ethane, C2H6, we gotta look at this. Well, we know since they're all negative, they're exothermic reactions, meaning that the number of 83 should be written on the right as a product if it's exothermic, okay? So we know it's one of these. It's either A or B, okay? Now, I gotta look. They've tried to trick you, and H is never by itself, okay? It's gonna be H2, hydrogen gas. So another kind of, they're trying to throw you in there. So it's A. Okay? There you go, 100%. And then the last sort of thing is just kind of a neat thing. This is how they do hot packs for cold packs. So, if a bag of ice can be used to treat energy, but a lot of times if you don't have ice, you use a cold pack. And they actually have this chemical reaction that happens. And when you squeeze that pack, it pops and the two substances kind of mix together, the water and the ammonium nitrate, and they dissolve in the water and it makes the bag cold. Okay, and then the hot pack will do opposite. Okay, it'll receive also this water and calcium chloride, and when they mix, it makes the pack hot. So they're exothermic and endothermic reactions. It's very kind of cool with that. So we're going to kind of put the last part about endopacks. So if it's releasing this cold, it's endothermic, I believe. Don't check me. Yep. So it's absorbing heat. Okay, so if it's endothermic, remember, it means it's greater than 0. Okay, so endothermic positive greater than 0. Okay. So how do we write that? Well, if it's endothermic, you write it on the left side of the arrow. Okay, if it was exo, it would be on the right side of the arrow. But nope, since it's endothermic, you write it on the left side. So this one is the opposite. It must be exothermic because it's getting hot. It releases heat. And then it's now going to be less than 0 because it's exothermic. Okay, and then exothermic we always write on the right side of the arrow. There you go. Okay, hopefully that helps you out a little bit. I know it is a little bit confusing as you go through it. If you need to visually see the two different graphs, it's very helpful to kind of see which one's going on. Pause this, use this for your quiz. Making sure you have kind of a list of, exothermic and endothermic, the differences of where you write the heat is very helpful as well. If you have questions, please always reach out to me, and I'll try to help you out, figure it out a little bit more.